Hello everyone, this is Giraffe. Today we are going to introduce an interesting human case. Terence Tao, the Mozart in mathematics, who won the Fields Medal in 2006. He brought us a lot of amazing ideas about mathematics, so we can take a glimpse of this area. Isaac Walter once said, "Only law is the law of physics." But Terence Tao challenged this. He said that the beauty of mathematics is you can change the rule. Let's take a look of his talents and interesting idea of math. The first one is Navier-Stokes. The Navier-Stokes is the equations governed in the field of fluid dynamics. We know that fluid has certain energy. Most of the time, if there's a drop of water on the floor, the water will go everywhere and it won't blow up because of the viscosity. It will dam out everything and won't blow up. But he has very talented idea. He noticed this phenomena and he was thinking, what if I can save all of energy of this drop of water? So he tried to design a special initial state to achieve this goal by changing the law of physics. But it's not change the law of physics in this reality, but in his mind, in his brain, which is to come up with some equations so that he could force all of the energy to blow infinite time. Very ambitious idea. The second one is the Coriolis conjecture. The Coriolis conjecture is a famous unsolved problem in mathematics. Start with any positive integer. For even numbers, divide by 2. For odd numbers, multiply by 3 and add 1. Repeat these steps. The conjecture asks, does every positive integer eventually reach 1? Let's take the example. Let's say 13. 13 is an odd number, so we can multiply 13 by 3 and add 1, then we got 40. 40 is an even number, we can divide it by 2, we got 20. 20 again, even number, divided by 2, we got 10. 10 the same even number, divided by 2, we got 5. 5 is an odd number, so multiply 5 by 3 and add 1, we got 16. 16, an even number, divided by 2, we got 8. 8, now please pay attention. 8, even number, divided by 2, we got 4. 4, the even number, divided by 2, we got 2. 2, the same even number, we got 1. Now here, please pay attention. 1 is the odd number, right? The odd number, we can multiply 1 by 3 and add 1, which we go back to the 4. 4, the even number, divided by 2, we got 2. 2, the same odd number, multiplied by 3 and add 1, we got 1. So here we come to a circle, a loop. We can never get out. So the trend is like no matter which number we choose, like we start from here, it is starting point. No matter how higher the number we get, but eventually we go down like this. The trend is like this. So it make me connected to the investment of stock. When people have a bunch of money, like $1 million, no matter how much money they earn in the middle, but from a very long time. At first, they have $1 million. Then gradually, they may earn a lot of money, reach the top. But eventually, almost all of the people who invest stock, the result, the ending line is the same. Is back to the starting point. Yeah, this is very simple mathematics question, but so far no one can solve this. It is just so simple, so elegant, so beautiful, but no one can solve it. So those two are his talents idea, his talents perspective about mathematics that I'm quite interested in. And when I do some research about Terence Tao, it reminds me of another mathematician, which is Gregory Perelman. Just like Terence Tao solved the Poincare conjecture, which is also very difficult math problem. He spent 7 years only focused on this problem by himself, seldom talk with people around. and he was offered the field medals, the biggest, the most important honor in the mathematics area, but he just walked away and said, I already solved the problem, now I don't need this. I already solved the problem, no need to take this prize. Then he just disappeared in the crowd. Both of them are amazing mathematicians with great minds. Yeah, so today we get a glimpse of the math community. Some people may say, why those mathematicians still spend so many days, so many years, like 7 years, or spend their whole life to solve this problem. We have AI, why not just like AI to solve it? But we have to admit, so far AI is still not that intelligent enough. Probably later on it can solve it, just like hundreds of years ago we still view the earth is a flat land, but now actually we are on a flying rocket and the earth is round. Yeah, so Terence Tao's story really inspired me. He is definitely a fox. If you ever heard about the hedgehog and the fox theory, the hedgehog is someone who really want to dive into one area and know everything into this field. And the fox represents some people, a group of people who can find the connections, who is willing to learn different areas and try to find a connection between different fields. So I think Terence Tao is definitely a fox. He also have a great opinion about AI. He's eager to learn AI, to combine math and AI together. And he admits that even some of the undergraduates probably know more about AI than him, but he still tries to lead this way, let the mathematics together with AI work together. So this is today's sharing of an interesting human case about Terence Tao. If you like this video, please subscribe to support. See you next time.